Long before we carved symbols into stone, before we told stories around campfires, before we made fire, someone was already watching us. Not the way we watch the sky, with backyard telescopes and wishful thinking. They had instruments parked on the dark edge of our own solar system, staring at Earth for millions of years, recording everything our planet ever did while we were still afraid of lightning. We discovered them by accident. And once we realized what they had, we had to decide whether we wanted to see ourselves through their eyes. Dr. Nia Park never believed in UFOs. An exoplanet astronomer turned techno-signature hunter, she made her career on the unglamorous side of alien hunting, looking for tiny anomalies in big datasets. Her group at the Deep Survey Array wasn't scanning the sky for little green men. They were scanning for non-random patterns in starlight and radio noise, the subtle fingerprints of technology. Astrobiologists talk about biosignatures, chemical clues like oxygen and methane in an exoplanet's atmosphere. Technosignature researchers like Nia look for signs of technology instead. Narrowband radio beacons, odd infrared glows from waste heat, transit shapes that look more like megastructures than planets. One night, Nia's team ran a routine scan on background data from beyond the ecliptic. Deep space. Supposedly empty. Her AI flagged something as a non-stellar, non-galactic, coherent scatterer. Which was a fancy way of saying, something big is bending our radio waves out there, and it's not a star, planet, or nebula. The anomaly sat about 600 astronomical units away, more than 20 times farther than Neptune. Too far to be a rock they'd accidentally missed. Too structured to be a random dust cloud. Nia overlaid the anomaly on another model. Her stomach tightened. It lined up almost perfectly with the focal region of the solar gravitational lens. According to general relativity, mass bends space-time and deflects light. Our sun acts like a lens. Light from a distant object skimming its surface gets bent inward and comes to a focus about 550 O away. At that distance, you could, in theory, build a telescope that uses the sun itself as the lens, able to resolve continents on exoplanets tens of light years away. NASA had white papers about this. No one had built it yet. Someone else had. At our own focal line. The reconstruction sharpened. A ring-like swarm, wafer-thin structures curved along the focus. Nia stared at it. "Tell me that's an artifact," she muttered. Her AI, Janice, replied in its calm voice, "Signal is consistent over 5 independent baselines. Confidence that object is real. 99.997%. She pinged the Deep Survey director. Within 24 hours, she was in a secure telepresence meeting with people whose names she'd only ever seen on grants. That's where she met Dr. Kofi Adeyemi and Dr. Mara Sane. Kofi was a mission architect at the Outer System Initiative, a Nigerian-born engineer who'd grown up watching Martian dust storms on live feeds. Mara was something else, an astrohistorian. She specialized in prehistoric skywatchers, what ancient humans knew about the stars, and when. When Nia explained the gravitational lens alignment, Kofi saw engineering. Mara saw intent. "Whoever built that structure," Mara said, "put it at our focal line. They're using our sun as a telescope." Nia frowned. "To look at what? The galactic center?" Mara shook her head. "At that focal point, the highest resolution images of a very particular object." She brought up a hologram. The orbit of a pale blue dot, 39 degrees above the ecliptic. Earth. "They built a telescope to watch us," Mara said. "And they did it a very long time ago. You don't ignore a possible alien observatory sitting just beyond your cosmic backyard." Kofi's team fast-tracked a mission, Vanguard 1, a fusion-sail hybrid probe with an onboard AI, Janice, in a hardened core. It would take 5 years at full burn to reach 600O. In the meantime, Nia and Mara rummaged through the only data they had, the way the object scattered background radio noise. It acted like a phased array, reconfiguring its surface to focus on different targets. And Nia noticed something odd. The main lobe of its attention wasn't always locked on Earth's present position. Sometimes the alignment lagged. Sometimes it led. It's like it's compensating for parallax, she said. Or, tracking Earth's orbit backward and forward in time. Mara cross-referenced those focus variations with her models of Earth's climate and albedo over the last few million years. It tightens its focus, she said, around 2 million years ago. That's when Homo erectus emerges, Nia said softly. Mara nodded. And right here, 700 or 800,000 years ago, its integration time drops. Temporal resolution increases. She didn't smile much. She smiled now, but it didn't reach her eyes. That's when we start seeing reliable evidence for controlled use of fire. From many light years away, you can't see individual creatures. But you can see spectrum changes in reflected light, vegetation, ice, deserts. Atmospheric chemistry shifts from metabolism, oxygen, methane. Thermal signatures from large-scale fires or industry. Fire changes a planet's glow. Large fires alter the thermal infrared output. Smoke and combustion products leave chemical traces. A sufficiently advanced observer, using a solar gravitational lens, could see even campfires on the night side of Earth. They were watching us, Mara said, before we had fire. And when we learned to make it, they zoomed in. 5 years later, Vanguard 1 reached the observatory. It wasn't one solid object. It was a swarm. Billions of wafer-thin elements, each a few meters across, arranged along a curved caustic line. A living optical system, using the sun to look backward along the line at Earth. Janice eased Vanguard through the gaps. There's no shielding, Kofi muttered, watching from mission control. No armor, they never expected company. At the focal point, Janice found something else. A dense cluster of devices no bigger than snowflakes, each holding a holographic lattice of matter. Memory. An archive. You can store information not just on surfaces, but in the interference pattern of light within a volume of material, three-dimensional optical storage. Extremely high density. Long-term stability. Resistant to radiation if properly designed. Janice gently grabbed one with micro-manipulators, scanned it with low-power coherent beams. It flooded. Images. Spectral datasets. Time slices. Of Earth. The archive wasn't continuous. It sampled. Sometimes every 1,000 years. Sometimes every few hours. Always the same world. Always the same small blue dot. Back on Helios, Nia, Mara, and Kofi watched the first decoded sequences. A cave mouth at night, seen from orbit. A faint orange glow flickering. Inside, silhouettes moved. The level of detail was beyond anything imagined. It wasn't just atmospheric spectra. It was high-resolution imaging from above, captured via the sun's lens. Herds of ungulates moving across savannas, rivers changing course, volcanoes erupting. Then hominins. Hunched figures at cave entrances, nursing weak, stolen flames. They can see faces, Nia whispered. From 600 using our sun as a zoom lens. The Watchers had been recording our entire planet's history, in chunks, for at least 5 million years. The archive went back even further. Forests stretching to poles, impact craters still steaming, a young Homo lineage quietly diverging. Mara's heart hammered. Her entire field, paleoanthropology had just been demoted to a rough sketch. "These shots from 2 million years ago," she said, "those are Australopithecines, or something close. And look at this." She froze the image. Somewhere on the African savanna, a small group of primates stood upright under a storm, eyes reflecting lightning. "Do you see their gaze?" Mara asked softly. "They're looking up. At what?" "Lightning, maybe. Stars, maybe. Or maybe, unknowingly, at an eye in the dark." In the 1960s, Ronald Bracewell proposed autonomous probes as a better way to explore the galaxy than beaming radio everywhere. A Bracewell probe could park itself in a system, watch for signs of intelligence, respond only when contacted. Passive. Safe. Patient. The observatory at 600 O was a kind of Bracewell system, distributed, using gravitational optics instead of a single local dish. But its archive never sent a response. It only watched. Until Vanguard arrived. There were 3 big questions. Who built it? Why watch us so long? Why start before fire? Nia argued for the simplest answer. They were surveying lots of planets. We were just lucky enough to have the right chemistry. Kofi thought like an engineer. Their array isn't cheap. You don't park one at every star. You choose targets that matter. Mara thought like a storyteller. She focused on the timing. Archive density spiked around key transitions. Emergence of tool using hominins. Control of fire. Rapid brain expansion. Dawn of agriculture. Industrial revolution. First radio emissions. It wasn't a random documentary. It was a case study in cognitive ignition. They wanted to see the spark, Mara said. Not just a fire, of mind. Maybe they'd seen planets with biology before. Maybe they'd seen intelligence before. But our curve, the way climate chaos, predation, and chance drove a particular ape into a narrow bottleneck where tool use and social brain exploded, was interesting. So they set up a camera before the show started. To watch the whole arc, from fearful primates stealing embers to a planet throwing probes out of its own system. Then Vanguard 1 showed up, and the camera finally had something in frame that could talk back. The last layer of the archive held a surprise. Hidden among the recorded light curves were simulations. They hadn't just watched. They'd modeled us. Variant Earths. One where hominins never master fire. One where an earlier species of human wins out. One where a pandemic in the Neolithic keeps agriculture from ever taking off. Per run notes in a compressed, alien markup language. Janice translated patterns. This one is tagged, failed cognition, it reported. This one, premature self-extinction. This one, premature stellar engineering. And on a run very close to our own timeline, the tag read, Emergent Cooperative Observers. Mara exhaled. They weren't just curious, she said. They were rating us. In some cosmological models, intelligent observers play a role not just in interpreting data, but in selecting which branches of possibility get realized in a meaningful sense. Call it the anthropic principle with teeth. If a network of old civilizations prefers universes where new minds arise and don't self-destruct, they might quietly promote those branches. By giving them a nudge, by preserving their records, by eventually inviting them to join the observing network. The observatory at 600 O started to look less like a peeping Tom and more like a quiet admissions office. The final piece arrived through Vanguard itself. As it drifted through the array, one of the nanoscopic data units activated. Not just a recording this time. A message. Ultra-narrowband, tightly collimated back along the lens line, then bounced inward by the sun. Earth's Deep Survey Array caught the echo a few days later. It was short. Janice reconstructed it. In alien data channels translated to human words, it said, "You have turned the camera back on itself. You have seen your beginning through other eyes. If you wish, you may see how we saw you. And you may one day watch others as we watched you. Or you may dismantle this lens and forget we were ever here." Both paths are allowed. Nia, Kofi, and Mara sat in silence as the message scrolled. It wasn't a demand. It wasn't a set of orders. It was an invitation to self-knowledge. And to participation. We don't know, in this story, which choice humanity makes. Maybe we keep the observatory intact, build our own receivers around it, and spend the next centuries learning about ourselves frame by frame. Maybe we augment it, aim new branches of the lens at other stars, and join a very quiet society of watchers. Or maybe we decide we've been watched enough, and let the array fall silent, its memory crystals drifting in the dark. What we do know is this: they were watching us before fire. Before we had language. Before we knew what stars were. Before it made any sense at all for anyone to care about us. They still watched. Not because we were special then, but because they knew how rare the spark of mind is, and how easily it goes out. In the end, the observatory at the edge of our system did more than show us that they were out there. It showed us ourselves, from the moment we feared fire to the moment we learned to light the sky. And it left us with a question only we can answer. Now that we know we were worth watching, who will we choose to watch, and for how long?